Okay, so again, we can use the models to estimate the intrinsic value of the stock. And because in equilibrium, the market stock price is going to be equal to and converge to the estimated stock price, the intrinsic value of the stocks. So when we see that stock price is below intrinsic value, we know that the stock price is going to go up in the future. Okay, and the stock is undervalued in the market right now, so it's a good purchase for the investors. And when stock prices are above the estimated intrinsic value from the model, we know that this stock is overvalued, and it's a good sell because stock price is gonna go down in the future to converge to the intrinsic value. If the stock market is reasonably efficient, gaps between the stock price and intrinsic value should not be very large, and they should not persist for very long. Okay, so again, the we have managerial actions, economic environment, taxes, and political climate, and any other factors to determine the true return and risk of the stock, and that determines the stock's intrinsic value. Okay, the true value, the estimated stock price. On the other hand, we have perceived return risk by the investors for the stock, and that decides the stock's market price. In equilibrium, again, we think these two would be equal to each other. Okay, we think the market perceived risk and return is going to decide on market stock price, and that's going to converge to the real stock price, real value of the stock. Okay, so that's our that's what we would do to after we estimate the stock price from the models, we would compare it to the real market price and to decide if the stock is a good purchase or a good sell. Okay, and we have 4 different major approaches to estimate intrinsic value of a stock, including discounted dividend model, corporate valuation model, PE multiple, and EVA approach. Okay, you can read our book for the 3rd and the 4th methods here, but we're going to discuss these 2 models in our chapter 9 notes here, the first 2 models. Okay, and besides evaluating the stock price, we will also calculate dividend yield for the stock, okay, which is D1 over P0, capital gains yield of the stock, CGY, which is P1 minus P0 divided by P0, okay, and these two add up to total return of the stock, which can be denoted as RI or RS. Okay, so it's the stock return for stock I. We can use either RI or RS to stand for it. Okay, and this group of terminology is very similar to the current yield and capital gains yield we learned in the bond chapter. Okay, remember for bond chapter we have current yield, which is CY, and it's coupon divided by P0, the price of the bond. Capital gains yield, CGY, it's exactly the same as here. It is the difference in the price change in bond, P1 minus P0, divided by P0. Okay, and the total return of the bond equals to current yield plus capital gains yield, which is also called yield to maturity or yield to call. Okay, and we use D1 here, dividend at year 1 end for the stock in the dividend yield here, dy, to calculate dy, we use d1 over p0. Okay, for stock dividend yield, we use d1 over p0. For bond current yield, we use coupon over p0. Okay, and for capital gains yield, we use price P1, price at year 1 end, minus the current price P0 for the stock, divided by P0. And it's the same formula for bond. Okay, and for total return for the stock, we use dy plus CGY, and for the bond, we use CY plus CGY. Okay, we're gonna calculate these in the coming examples. Okay, so let's look at the first model to price a stock. Discounted dividend model. The value of the stock is the present value of the future dividends expected to generated by the stock. So our general philosophy here is to discount all the future dividends from D1, D2, D3 to D infinity by using the appropriate discount rates, 1 plus RS, 1 plus RS square, 1 plus RS cube, 1 plus RS infinity. Okay, we discount all the future dividends using stock return, RS, which is also RI in the CAPM. So we have P0 hat, estimated stock price. Okay, so this is our discounted dividend model. Okay, and we want to simplify this model. Okay, in a special case where a stock whose dividends are expected to grow forever at a constant rate g, we can simplify this model to constant growth model. Okay, if we assume that d1 equals d0 multiplied by 1 plus g, d2 equals d0 multiplied by 1 plus g2, dt, dividend at any given time t, equals d0 multiplied by 1 plus g to the power of t, then we know the dividends are growing at the rate of g, okay, forever. In this case, we can replace d1 by using d0 multiplied by 1 plus g, replace d2, replace d3, so the formula would be like here. Okay, and this is actually a geometric series. Okay, if you multiply, for example, for the first item, if you multiply by 1 plus g over 1 plus r, you would get the second item. And if you multiply the same thing, you would get the third item, so on and so forth. Okay, so we can use the summation formula for the geometric series. Okay, I'm not writing it here, but if you're interested, you can study that after class on your own, or you can schedule again a Zoom conference with me if you want to know the details. Okay, but you're not required to know the derivation process here in our class. But anyway, if you replace all of these into the into the equation 1 here, you would have this complicated equation, and we can simplify it by using summation formula for geometric series. And then we would have a very simple formula here, formula 3. Okay, that P0 hat, estimated stock price, would be equal to D0 multiplied by 1 plus G over RS minus G, which is the same as D1 over RS minus G. Okay, so we simplify this long formula to this simple short one if we assume that all the dividends are growing at the rate of g. Okay, and we call this constant growth model version of the dividend discount model. Okay, here D0 is the dividend just paid. Okay, dividend given out at time 0, it is already paid. So if you're purchasing the stock paying P0 for now, you're not gonna get this D0 who is already paid. Okay, you only have D1 after you purchase the stock at time 0. You only get dividend D1, D2, D3, and all the future dividends. Okay, but not D0 anymore. G is the dividend growth rate constant. RS is the stock return. Okay, so for here, because P0 equals D1 over RS minus G, we can also infer that PT, stock price at any time t, is dt plus 1, dividend at time t plus 1 over RS minus G. Okay, so we can calculate stock price at any time by using dividend next period over RS minus G. Okay. Also from this model, we can know that this RS equals D1 over P0 plus G. Okay, we can get this from this original model. Okay, you can notice there are only 4 variables here: P0, D1, RS, and G. You can always get one of them if you know the other 3 ones. So G would become RS minus D1 over P0. RS would be D1 over P0 plus G. Okay, so if we look at this graph here, we would know dt, okay, dividend and anytime t equals d0 multiplied by 1 plus g to the power of t, because we assume that dividends are growing at a constant rate g. So dividend in the first period could be 0.25, and for period d1, d2, it is growing up constantly. Okay, and for the present value of dividend t, it is going to be dt over 1 plus r to the power of t. Discount the dividend one by one. It's going to be smaller and smaller. And our stock price P0 is going to be the sum of the present value of the dividends. Okay, adding the present values. Even though the present value of dividends are going down, but P0 is still going up as because we're adding more and more dividend present value. Okay. Some other information we know from the constant growth model. So here are 2 important conclusions we have concerning this constant growth model. Okay, you better remember them, memorize them. But I'll show you the derivation process here too. Okay, the first thing we need to know is that we assume that the growth rate of dividend is G under constant growth model. However, growth rate of price should be also G. Okay, we know that dt equals d0 multiplied by 1 plus g to the power of t. But at the same time, PT, stock price at time t, also equals to P0 multiplied by 1 plus g to the power of t. Okay, this is the proof. From the original constant growth model, P0 equals d1 over Rs minus g. And we also know dt plus 1 equals d1 multiplied by 1 plus g to the power of t. So pt becomes dt plus 1 over Rs minus g. And dt plus 1 can be replaced by using d1 multiplied by 1 plus g to the power of t. Okay, so and if we divide by Rs minus g, this becomes pt. And we know that this first part, d1 over Rs minus g, it is also p0, so we can replace it again. So our pt becomes p0 multiplied by 1 plus g to the power of t. Okay, the growth rate of stock price is the same as the growth rate of dividend, and they're both g. This is the first conclusion. The second conclusion is that our capital gains yield for the stock becomes G. Okay, remember capital gains yield is the difference in price divided by original price, right? So it's the growth rate of stock price. It is G. Dividend yield is D1 over P0. It is R minus G. Okay, because in the original model, P0 equals D1 over Rs minus G. We can change this model a little bit. D1 over P0 becomes Rs minus G. And we know dividend yield is by definition dividend 1 divided by P0. So it is just R minus G. Okay, and because Rs, the total return equals D1 over P0 plus G. Okay, and what by definition we know this first part is dy. So the G becomes capital gains yield, okay, because we know dy plus capital gains yield is the total stock return Rs. Okay, so we know the first part is dy, dividend yield, and the second part, G, is capital gains yield, which is P1 minus P0 over P0, which is growth rate of price. Okay, so from the original model, Rs equals d1 over p0 plus g. And the first part, d1 over p0, is the definition of dividend yield. G, capital gains yield, plus dividend yield should be total return. So G is capital gains yield. Okay, so that's another conclusion, that G is capital gains yield. R minus G is dividend yield under the constant growth model. Okay. The third thing we need to note is that in this model, P0 equals D1 over Rs minus G, we should have a positive stock price, and because dividends D1 is positive as well, so our R minus G should be positive. Okay, R should be larger than G, the growth rate. If G is larger than R, the constant growth formula leads to a negative stock price, which does not make sense. Hence, the constant growth model can only be used if R is larger than G, and G is expected to be constant forever. Okay, we want a positive price. Dividend is positive, so R minus G has to be positive, and R has to be larger than G. And G has to be constant forever. Okay, these two are two basic conditions for using constant growth model. Okay, again, constant growth model can only be used if a company's growth rate is expected to remain constant in the future. This condition almost never holds for new startup firms, but it does exist for many mature companies. Indeed, mature firms such as Allied and GE are generally expected to grow at about the same rate as nominal gross domestic products, that is, real GDP plus inflation. Okay, it is telling us that we usually use constant growth model for mature firms when their growth rate is similar to gross GDP, okay, which is real GDP plus inflation. Okay, for those startup firms, usually they have a faster growth rate in the beginning, and then when they become mature, they're going to have this stable G that's almost gross GDP. But so that would be the non-constant growth model. Okay, we also call it two-stage model for those startup firms, and we would discuss this more complicated case, two-stage model next class, chapter 9, class 2. Okay, for class 1, we will be focused on constant growth model for the mature firms, where we have a constant G. Okay, I guess I'll pause the video for now, and from the next video, we're gonna discuss some of the examples using constant growth model.